Hello students, welcome back to our data structure question and answer series. Here I am going to explain the next important questions for your data structure interview preparation. This is again useful for your university exams also. Okay, the question is like this: what is space complexity? See, whenever we want to solve any problem with the help of computer system, then there are many solutions for that problem. Suppose you want to calculate factorial of a number. There are two ways to solve this problem. Basically, the first thing is you can use their for loop, like from 1 to that number you have to multiply each and every time and you will get factorial of a number. Second way is with the help of recursion concept also we can solve that problem. Getting means a single problem can be solved with the help of multiple ways. And which way is better, how to calculate that? There is a concept in data structures, that is a complexity, like space complexity and time complexity. Now here the question is, what is space complexity? Amount of memory space that an algorithm or problem takes during the execution. Means suppose you have selected any algorithm for solving any particular problem with the help of program, you can say, means computer. Then if you want to find out which one is better, then you can calculate their space requirement of that algorithm, and that space requirement is nothing but a space complexity. Whatever algorithm taking less space, that is always better. Okay, means memory consumption is less, than that is the better one. For example, there are multiple sorting algorithms, like there is a bubble sort, insertion sort. Sorting means what first? See, sorting means arranging data in ascending or descending order. That is nothing but a sorting concept. There are multiple techniques available in data structures for sorting, like bubble sort is there, selection sort, like insertion sort, merge sort, radix sort, quick sort. All these algorithms are different, means all are having different technique. Okay, for example, in bubble sort, what we do, if you want to sort data in ascending order, then whatever maximum element, that will be bubbled up at the end. Means there is a comparison between the first element and the next one. If first one is greater than the next one, then we swap it. In this way, there are multiple swappings, multiple comparisons, multiple passes are there in bubble sort. Now in insertion sort there is somewhat different technique, in selection sort somewhat different technique, and so on. Means all these sorting algorithms are having their own techniques, and whatever space requirement by all these algorithms, that we have to consider. The algorithm which is taking less space, that is always better, that is efficient. Getting means space complexity of an algorithm is nothing but a space or memory required by that algorithm to execute it. Getting? See, what is this space exactly? The space required for instructions. Instructions means whatever algorithm you have written, those instructions you have to store somewhere inside RAM for its execution. Those instructions taking some space, that is nothing but instruction space. Next is environmental stack, means suppose your algorithm is having multiple internal function calls. For example, there is a recursion concept, suppose. Then there are multiple function calls, okay, and those should be stored onto the stack for temporary purpose. Those functions calls are also taking space, that is environmental stack. And the next one is data space. You have to declare some variables in your algorithm, in your program. Those variables are taking some space. Then constants are there, other data again may be there. That whole space you have to consider here while calculating space complexity. Again, one more point, see, whatever variables you have declared, as per data type you have to calculate the space requirement. This all space you have to consider. And one more point is there, that is space used for input values. Means you have to accept input from user in your algorithm, in your program. That space also you have to consider. Okay, means according to that input value, whether it is changing or not, everything you have to consider. Means space complexity can be calculated with the help of formula like auxiliary space plus space used for input values. This auxiliary space means this one, whole part, that is instruction space, environmental space, variable space, constant, getting, plus space used for input values. Normally space complexity, or again there is one term, that is time complexity, that we have to calculate in the terms of big O notation. Okay, big O notation means that is for calculation of worst case complexity. Worst case means maximum requirement, here you can calculate. Okay, now here see, one function is written in C language, this is returning one integer value, and here n value is the argument. Now here this function is to calculate sum of natural numbers up to n. Getting means first n natural numbers you can say. For that this function has been written. Now see here one I variable is declared, sum is declared, and from n to 1 you can say here reverse loop is written. Now from n to 1 we have to do sum equals to sum plus I, means here n first will be added inside sum, then n minus 1, then n minus 2 up to 1, or you can put normal loop like from 1 to n, that is again same here, and whatever calculated sum that is written here from this function with the help of return statement. Now this function is for doing addition of first n natural numbers, that n is nothing but a argument. Okay, and this function, see here n is the input value, but that is fixed. If n is 5 then no problem, it is taking the same space, whether n is 5, whether n is 1, whether n is 10, anything it may be, but whatever storage required for that n, that will be always same. That's why again I variable and sum variable, these are again fixed. Okay, means according to n whether it is changing, that means space requirement is changing or not, that we have to consider. Here according to n space requirement is not changing, it is fixed. That's why we can say that here space complexity is equal to big O of 1, means constant. According to n it is not changing, that's why it is constant, that is big O of 1. Getting? This is the overall concept of space complexity. Space complexity means the memory space that an algorithm or a problem is taking for its execution. See, with respect to an input value is always considered. The formula is space complexity is equal to auxiliary space plus space required for input values. And here instruction space, environmental space, and space required for variables, constants or other data, that will be considered. And see, you have to keep in mind the worst case space complexity for all sorting algorithms. Like here I have mentioned like bubble sort, that is big of 1, insertion sort big of 1, selection sort big of 1, heap sort big of 1, all are constant fixed, it is not taking any extra space according to input, means input is changing, then also the space is fixed. That's why here all algorithms, these algorithms are taking constant space complexity. Now the next one is quick sort and merge sort. Here big of n c, quick sort and merge sort. Here according to n the space requirement is changing. See, these are actually divide and conquer techniques. Here recursion is used again. Okay, that's why that array, whatever you are considering, that input data, that should be divided and again stored somewhere. Okay, that's why these two algorithms are taking space complexity, worst case space complexity big of n, but these are having worst case space complexity, that is constant big of 1. Again whatever required space complexity for remaining algorithms, like there is a radix sort, bucket sort, or and so on, that you have to keep in mind, just go through it. Getting? Now let us see the next question. What is time complexity of an algorithm? See, we have already seen space complexity is nothing but a space required for an algorithm to execute it. Again the same thing is here. In case of time complexity, we have to compute time requirement of an algorithm. See, time complexity of an algorithm quantifies the amount of time taken by an algorithm to run as a function of length of the input. See, you may think like this is very much complicated. See, don't worry, it is very easy. Here, with respect to input, we have to compute the time complexity, time requirement of an algorithm. Means, whenever the input is changing, then whether the time requirement for an execution of that algorithm is changing or not, that we have to think here, that we have to consider here. Means, with respect to length of input, whether that time requirement is changing for that algorithm or not, means whether it is fixed, or if the input is n, then according to that n the time is changing, that we have to find out, that function we have to find out, and that function represents the time complexity of an algorithm. See, here I am explaining some examples, that's why don't worry, you will get better idea here. See, the time complexity of an algorithm quantifies the time required for an algorithm for its execution with respect to input value. Means Time complexity of an algorithm quantifies the amount of time taken by an algorithm to run as a function of length of an input. Means here you have to consider the input value for that algorithm. If input is n, then according to that n, whether the time requirement is changing or not, that we have to find out. Means we have to find out a function that will calculate or that will represent the time requirement of an algorithm with respect to input value n. Getting? That is nothing but a time complexity. How to find time complexity? See, here algorithm is having multiple instructions in it, or you can say program is having multiple instructions in it. All the each and every individual statement you have to consider how much time it is taking, you have to consider, and you have to add all the instruction execution time, and that will represent the time complexity. And according to the computed time, you have to find out function with respect to n, that is input value. Here see, the time required to complete a program is equal to the sum of number of times each statement gets executed. Means say, see, there is a looping statement, then that is executed again and again and again, means that is taking more time. That you have to consider here. Getting? In case of space complexity, that doesn't matters. Now here see, while calculating time complexity, we have to compute running time of an algorithm, that is nothing but a time taken by that algorithm for its execution. Here we have to consider some assumption like all the arithmetic and logical statements will take 1 unit, and again return statement will take 1 unit, and considering these two assumptions, we have to find out the running time and running time of that algorithm, and then we have to find out the time complexity. For example, see here one function I have written, that is sum of numbers. Simple two numbers I want to add. Then how we write function like this? Function name is sum of numbers. It is returning one integer value and taking two arguments a and b of type integer. Now here I have computed like integer c equals to a plus b. Means just we are adding a plus b and storing inside c, and then return c. These are just simple statements in this function. Now we have to compute running time. Now here assumption is all arithmetic and logical statements are taking 1 unit, and return statement is taking again 1 unit. Now see here the first statement like int c equals to a plus b. Int c means here we are declaring one c variable, and we are adding a plus b here. See, a plus b we are adding first, that will take 1 unit of time, and then whatever computed value that we are storing inside c, that is taking 1 unit. That's why this statement will take 2 units of time, and return statement is taking 1 more unit. That means this algorithm or this function is taking 3 units of time, and it will never change. A and b value, it may be anything, but this 3 unit time will never change. That's why we can say that time complexity of this algorithm is big O of 1. See, big O is a asymptotic notation that will represent worst case time complexity. There are again two notations like omega and theta. Those also we can use to represent like best case and average case time complexity. Getting? Now here worst case we are always considering, it is always better. That's why this is taking constant time complexity. That's why we can represent time complexity of this algorithm as big O of 1. Now the next example is, see here sum of array elements if you want to do. See here we have to use looping, okay, and according to the size of that array it will vary. Getting? Now see here the statements are like this: sum equal to 0. Here I have initialized sum to 0. Then from 0 to less than n. See, 0 to less than n means this n indicates the number of elements in that array. Always index starts with 0 and ends with size minus 1 in case of array. In the previous video also we have discussed about array concept. See, then 0 to less than n, we have to compute the sum of array elements, means sum equals to sum plus a of I. Here we are taking one by one array elements and adding inside sum, and finally whatever calculated sum here, that is returned. Getting? Now for this function we have to compute running time. Consider cost. Here we have to calculate according to this cost. We will consider a number of times that statement, how many number of times that statement is getting executed, that we will consider here. See, sum equals to 0, 1 unit, it will execute only once. Here for loop is executing, see here 0 to less than n, but see finally it will again check for the condition. Okay, that's why see this statement will get executed n plus 1 number of times, and see here 2 units it will take, because each and every time it is checking for condition, and second it is incrementing the value of I, means that these two statements will get executed again and again. This will only once, this I equals to 0, that initialization will be only once, that is constant, I am not considering here, but this is changing. Okay, means every time condition will be checked and every time the increment will be done. That's why it will take 2 unit cost, and number of time it will execute n plus 1 number of times. Getting? Next, sum equals to sum plus a of I. See, sum plus a of I, this part will get executed, that is 1 unit cost, and then next it will be added inside some variable, that is the next, that is 2 unit it will take. Cost will be 2 unit, actually that is the amount of time we are considering here. And how many times this statement will gets executed? Of course n number of times, because this array is having n elements in it. And finally this return statement only once, and cost is again 1. See, if you calculate the addition of cost into number of times, and if you add all the instruction time requirement, then you will get here the value 4n plus n. Now you can say that the time complexity of this algorithm is big O of n or order of n. This is called as a linear time complexity. Getting? If your algorithm is not having any looping instruction or any complicated instructions, then always the time complexity is constant, and that will be represented by big O of 1. If your algorithm is taking any array calculation or any loop, single loop, then that time complexity is always big of n, and that is always linear. If you consider a nested for loop like this, means see, in a matrix manipulation there is a nested for loop, there the time complexity is big of n square. In that case, that is called as a quadratic. Getting? The time complexity of an algorithm is a way to just quantify the amount of time required by that algorithm with respect to input size. Here we have to compute, or we have to find out a function according to the input. Okay, if your algorithm is taking less time or constant time, that is always better. See, you have to just go through the time complexities for all sorting and searching algorithms. That will be helpful to you, and that is always asked question for interviews again in university exams. Getting? Now the next question is, what are asymptotic notations? See, we have just discussed time complexity and space complexity of an algorithm. The time and space complexity we can represent with the help of some notations, and those notations are called as asymptotic notations. Mathematically, if you want to represent time or space complexity of an algorithm, then for mathematical representation we can use asymptotic notations. There are basically 3 notations like omega notation, theta notation, and big O notation. All these notations are for best case, average case, and worst case time complexity. Now what is this best case? Means suppose you are considering time complexity. If algorithm is taking less time, whatever minimum time taken by an algorithm for its execution, that is nothing but best case time complexity, or again that is same for space complexity. See, here I am considering time complexity. See, best case time complexity means if algorithm is taking less time, whatever minimum time taken by an algorithm for its execution, that will be represented with the help of best case time complexity. The notation that is used for expressing best case time complexity is omega notation, and always it is representing the lower bound of your running time. Lower bound of running time means minimum running time taken by an algorithm for its execution. Next one is, see, average case time complexity means average bound of that running time. Okay, means average time taken by an algorithm for its execution. That will be represented by theta notation. And the next notation, that is nothing but big O notation, that is worst case time complexity, means maximum time taken by an algorithm for its execution. That is always in worst case. Okay, and that will be represented by big O notation, that represents the upper bound of running time if you consider graph. Okay, that is nothing but maximum time taken by that algorithm. These are 3 asymptotic notations. Just remember remember, asymptotic notations of an algorithm, that is nothing but a mathematical representation of algorithms complexities. The best case time complexity, that is nothing but minimum time taken by an algorithm for its execution, that can be represented with the help of omega notation. Average case time complexity, that is nothing but average time taken by an algorithm for its execution, that can be represented with the help of theta notation. And big O notation, that is for worst case time complexity, that is nothing but the maximum time taken by an algorithm for its execution. Getting? These are three asymptotic notation. In this session, I will stop here. In the next session, we will discuss some more important data structure exam questions. Till that, take care. Bye bye. Thank you.